Okay, good afternoon, everyone. Welcome to our webinar. I'm Luke, the head of product engineer from SINEXCEL, and welcome Maxim Xie, overseas sales manager from GreatPower. Really happy to co-host this webinar with you. So the topic of our webinar will be like 5 parts. So the first one will be like brief introduction for both company, and the second one will be some solution introduction for the battery trends in some industry. And also the third part will be like some practical value in real projects. And then with the joint discussion and Q&A section, we will finish all the webinar. So let's begin the first part. So let me introduce our company. So we are focusing on the different field like energy storage, power quality, and also smart charging, and also the battery testing the system. So in the past 18 years, we sales our product to over like 60 countries, and also we have like 600 partners all around the world. And for different country and a different location, we have already have like a 5,000 and more on the on-site project. And also with 8 gigawatt PCS shipped, and we coordinate with like 20 gigawatt hour battery energy storage served. And this is our global footprint. We have a lot of office, like different part from California, and it was Dusseldorf, and it was like Australia, and also the headquarter is in Shenzhen with our R&D centers. And we also have two different factor in Xi'an and Suzhou. And this is our milestone. So we founded in 2007, and the first modularized PCS was public in 2011, and in 2017 we did an IPO publicly in the market, and in 2023 we shipped a gigawatt in single 1 years. And in 2024, we won the first place in China's C9 storage with modular solution. And in 2025, we launched our Sirius 135K. And this is like the overview for our product. So as you can see on this diagram, we have different PCS from 30 kilowatt to like 1.7 megawatt, and the 135K is in the left part of this diagram. This is our really good product. Welcome, Maxim Xie, introduce about GreatPower.
Good afternoon, everyone. So let me briefly introduce GreatPower. GreatPower, founded in 2001 and publicly listed in 2015, is a technology-driven enterprise specializing in the research, development, production, sales, and service of batteries and energy storage systems, with numerous patents and a key role in shaping 25 national and industry technical standards. We lead the industry in innovation. Our products span energy storage, consumer electronics, and power sectors, earning widespread recognitions for their safety, efficiency, and long life cycles. We have consistently ranked among the global leaders in several key areas, with a track record of zero safety incidents in project installations. With 12 manufacturing facilities and operations spanning over 50 countries and regions, GreatPower offers comprehensive solution to meet the diverse needs of clients and partners worldwide. With 12 state-of-the-art production hubs, cutting-edge automation, and a team of seasoned experts, we ensure top-tier quality and consistency in every product we deliver. So totally production capacity per year is 60 gigawatt hour right now. Starting from 2024, GP has been a Tier 1 manufacturer. We have partners from the consumer batteries to right now the BESS system.
Okay, thank you, Maximum. Let's move to like part two, the industry and the battery trends, where we can explore market drives shaping our solutions. So this is the trend of the battery technologies. So we want to brief introduce this.
Mm-hmm. Sure. As you can see, the figure, like the lithium phosphate batteries, I think it will remain the absolute core technology for stationary storage over the next decades, maintaining a share above 80%. And for the sodium-ion battery, it will become the second largest technology, exceeding 10% share by 2035. It's suitable for large-scale, low-cost, and storage scenarios. And for the rest batteries, I think hold a small but stable share. So about this question, how advanced battery technology enables higher system value and new application opportunities. First is to improve the energy density. As you can see, once a single battery cell has a higher capacity density, it can enable the whole BESS system a larger capacity, but still keep the same size. And the second is to enhance safety and stability, like to use some fireproof material to keep all the systems safer. And thirdly is the longer lifespan and durability. To use the BMS and EMS. As the AI, you can control the whole system to keep it safer and make it a long lifespan. And also, it's better to develop the charging capacity. Like right now is 0.5C, and maybe in the future, like all the batteries will be 1C or even like faster charging. And also, if like the batteries in the future, I believe have a greater efficiency, which means has less energy losses, and this enable to achieve the whole system a higher RTE. Yeah.
Okay, thank you very much. And based on this, in line with the continuous upgrading of the battery cells, the industry faces like some significant integration challenges. We can see some like a grid connection complexity with varying voltage or frequency things, and a different standard with like different power quality requirements. Like we encountered diverse like load types and also the high load quantities in the industry parks, and then we operate in like really harsh environments like deserts, like island, like mountains, like some extreme cold condition, and with like a heavy rain areas. So and also some like for the life cycle, like we probably face some like uneven investment returns due to some like high capex or some high opex. So in line with like continuous with these things, we launched our like a Sirius like a 135. So that's what we call like global ready, scenario ready, and life cycle ready. So global ready means we can stand with multiple voltage adaptation. So we can support like a 208, 400, or 480 AC. And with some like a multiple certification coverage, we can support the like the grid code from all over the world. For example, like North American, like Europe, and even for some Latin American certification. And then for scenario ready, that means 100% unbalanced load support. and some like we can support or say we can stand with harmonic about like or around like 25%. And for some microgrid and off-grid island, we can support the like a fully off-grid running, and also with some like large scale events for like a similar switch from on-grid to off-grid. We can support with really a fast switch to the most change, and also with the extreme environments. The enclosure of our 135K is IP65 and also is like C5 rating. And we can guarantee like 55 degrees C for like full power operation. So this is scenario ready. And for like a life cycle rating is about like a the maximum return of investment. More like the efficiency of the PCS is like more than 98%. That means like less energy loss, and also the modular design minimize the OPEX, and we can guarantee some like multiple parallel that can ensure with some availability and also some reliability for some large scale power. So this is just isn't just a product, it's like the value unlocking the platform for the equipment to the system. And Maxim, would you mind to introduce your roadmap about the battery part?
So as you can see, whether it's battery cells, outdoor cabinets, or containers, they are all developing towards higher capacity density and large individual capacity. The cost performance is crucial for customers, as larger individual capacity means lower unit prices and higher space utilization. This is an industry trend and also the goal for GP's product development.
Okay, very good. And so let's go to like the third thought about like critical value in some real development. I think we have some cooperation in some real project, right?
Yeah, this is GreatPower's and SINEXCEL, corporation's 20 megawatt hour project in Poland, which uses 5 megawatt hour DC containers and SINEXCEL 1725 series PCS, 1250 kilowatt PCS for a 10 megawatt AC block connected to a medium voltage transformer purchased by the customer in Poland locally. And the SINEXCEL PCS not only has EU certification, but also Poland's Great Connection certification, perfectly meeting the needs of customers. The response of SINEXCEL German after-sales team is also very quickly able to arrive to the project site for debugging. Yeah.
Okay, thank you very much. That's a true partnership. So this leads us perfectly to the like part 4. So some joint discussion about battery and the PCS, how to co-driving the future of the energy storage. So probably the first topic will be about how better BMS and PCS coordination enhance the safety and the system control. So Maxim, how do you think about this?
I think the BMS and PCS coordinations, it can enhance safety, to prevent overcharge or over discharge. BMS provides real-time cell voltage and state of charge data. The tight connection ensures PCS immediately reduce the charge currents or halt charging when cells approach voltage limits. Similarly, PCS stop discharge at minimum voltage thresholds to prevent damage and instability.
Okay, perfect. And also based on that, I think we can also coordinate based on some hardware. For example, more and more PCS is supporting with extra interface on digital I/O to transmit the fast signal to make sure all the protection about fault and some damage will be protected under maybe 10 milliseconds. So that's really important things to guarantee the system safety. And the second part will be the impact of digitalization and the modularization on the system efficiency. So, Maxim, how do you think about like the digitalization to improve the system efficiency?
So you know the digitalization. I think connecting numerous digital tools and ensuring like seamless communication between like the modules requires robust architecture and standards. Also, like the significant investment is needed in digital infrastructure, tools and skill development, as well as in the modular like design process itself. And for the interface management, the well-defined, stable, and standardized interface between modules are critical. Poorly managed interface becomes source of inefficiency and error.
Okay, thank you. And also from the PCS part, I think like modularized design for the whole system will be um, better. Why? Because for example, as like all-in-one solutions, the different module PCS module can control different strain of the batteries. So to make sure there are no SOC or say the system efficiency will be like not be wasted, and also to make sure the whole system availability to guarantee like at least one string get fall down and the other will remain operating, right? So I think that's the impact from modularization, and also based on the PCS part, digitalization with some self adaptive algorithm will be is kind of like the AI or say artificial intelligence algorithm to have to do the calculation about the output. So I think will be this would be some significant part. And for the last topic, the joint innovation. So now we probably are foreseeing the future technology trends. Like for example, for the PCS part, we are on the research of the liquid cooled PCS. For this part, we can improve the thermal performance for PCS. It can suffer with more severe environments, like with higher temperature. Also, on the liquid cooled PCS, we can suffer with more extreme environments with higher moisture or some higher uh, altitude, right? So this is probably in the technology we are foreseeing, but also we are facing some risk and also challenge. For example, maybe in 10 or 5 years ago, the battery changed from air cooling to liquid cooling. They're facing some like a liquid leak something or reliability things for the this new technology. So we are facing some same challenge on the liquid cooled PCS. So how do you think about the future of the battery part? For example, like a battery cell?
So I think like the standardized and smarter BESS system could optimize the efficiency and economics. Like the intelligent algorithm predict price fluctuations and load demand to select like optimal charge discharge times, maximizing economic benefits, right, and minimizing the operating costs. Also, it can enhance the grid support services and extend the lifespan and improve safety.
Okay, thank you very much. I think this that vision of now like intelligent battery energy storage system is what drive us both, right? And now we really thank you about the opinion shared. And then let's go to like the part five. So Q&A session. So do you have some questions?